Good morning, everybody. How are you doing? Welcome back to the second day of class here in the spring semester. See, we've got 9 viewers on there. Good morning, Hannah. Good to see you. Brittany, thanks for listening at work. Please, the broadcast should be pretty smooth today, but if you would, please report any sound or video problems to me in the chat bar. How's everybody doing? How's your first week going? Good to see you, Joseph, Julia, John. Wow, thanks everybody. I really appreciate you coming today. Don't forget, discussion board or collaboration activities are due tonight by 11:59 p.m. You either have to complete the discussion board by typing in 3 complete responses, or you can come to the webinar that is available tonight. If you already came to the webinar last Tuesday night, your discussion board collaboration is already finished for the weekend, so you don't need to do anything more. I'm doing pretty well, Brittany. I really appreciate you asking. Hi, Melody. Oh, wow, Trevor. I see we have Trevor in the house. Fantastic. Wow, it's a good crowd today. Hi, Butt3. Um, At any time during this broadcast, if you do have a question or comment that is relevant to the class lecture, please feel free to type it in the chat bar and I will discuss it as soon as possible. If anybody in the chat bar knows the answer to a question that a person asks, feel free to help me out by answering that question. I see we have Sarah in the house as well and Isaiah Drummer. Isaiah, I just updated your remind grade in Blackboard about 2 seconds ago, so you should be able to see that. Okay. Hi, Gabriella. Good to see you. So today we're talking about the second half of chapter 2. Let me see. Hold on. Let me get all the way back to the right place. I've been messing with. There we go. Goodness me. Here we go. Chapter 1, the steps of the scientific process. We're going to be talking about science, the science of psychology. If you remember from the last lecture, I suggested to you that what differentiates thinking psychologically from psychology as a science is the measurement and observation that is a part of the psychological process. And so that's what we're going to be talking about today. Talk about the steps of the scientific process. Then we'll talk about 3 different ways of gathering data to support the theories that we make. And this is descriptive research methods, experiments, and correlations. Now, some videos that you folks might find useful. I'm going to be talking about experiments and correlations um, in class today, and sometimes it doesn't come across quite as clearly as I would like. Maybe I don't describe it as well as you need. Maybe you miss a sentence or two during the lecture and you don't quite understand it. If you need help understanding any of the concepts that we talk about today, go look in this week's course resources folder and you will see 4 videos which will help you with today's content. So there's information about the APA division, steps in the scientific process, random assignment, and experimental research. These are all very interesting videos that you might find useful. Okay? So let's go ahead and get started. If you remember from uh, Tuesday, I suggested to you that psychology is a science because it uses observation uh, and measurement. So psychology is a science. What I'd like for you to know really is that science as a word it means method. You can really put in place of science the word method. That's what science is. Science is not a particular area. It's not biology. It's not chemistry. It's not psychology. Science is actually a set of tools for observing and measuring the world that allow the scientist the highest probability of gathering the correct information. Just a question here. Webinar is tonight at 7 p.m. Okay, so science is measurement. And here's the deal, science works in sort of this interesting way of rationality and measurement. So the scientist comes up with a theory or an explanation of something that they see in the real world, and then they develop a testable hypothesis that can then be tested using observation and measurement. Okay, so science is this leapfrogging procession of theory and hypothesis, theory and hypothesis, theory and hypothesis, theory and hypothesis. So a theory is an explanation of why something happens. Now you can go in on YouTube or Google and look, and there are tons of different definitions for exactly what a theory is. But a theory is really an explanation about why something happens. So here's an example of a theory that I might give you. Low self-esteem is a result of lack of social interaction. So basically, I'm saying people have low self-esteem because they don't have enough social interaction. That's a theory, and we could actually test that theory by making some measurements. And our theory would be tested using the following thing. A hypothesis is simply a prediction about something that you should be able to observe if your theory is true. Can anybody tell me another definition that maybe you were given in high school or junior high by one of your teachers? What did they tell you a hypothesis was? Do you remember that two-word definition that your teacher probably gave you? Can anybody tell me? Can anybody tell me what was that two-word definition that most science teachers will use to describe a hypothesis? I'll give you just a second. An educated guess. Does anybody ever remember hearing that from your teacher? An educated guess. Absolutely, Melody. An educated guess. Do you know why it's an educated guess? Because it's based on a theory. The theory is the education. So it's a guess based on the fact that you think a particular theory is right. Okay. Now, so our hypothesis, if we think that low self esteem is a result of lack of social interaction, then if we find a group of people and ask them how many friends they have and ask them to evaluate their self esteem, what we will probably find, what we would hope to find, is that the people with more friends would have higher self esteem, and those people with less friends would have lower self esteem. So we could actually measure our theory by going out and simply asking people, how many friends do you have? And we could then give them a self esteem questionnaire to measure their level of self esteem. And if our theory is correct, then we should support our hypothesis by finding that people with more friends have a higher higher self level of self-esteem. And so this is how things work. You develop a theory, then you test it with a hypothesis test. If your hypothesis is supported, then you may suggest another theory to further test, another hypothesis to further test your theory. If you find out that your hypothesis doesn't support your theory, then you have to change or just get rid of your theory. And so that's sort of how science works. Now, your book's going to talk about the steps in the research process, and it even has a chart that looks like this way over here on the left. And I'd like for you to be familiar with the basic 5 steps in the scientific process. As I suggested to you a minute ago, we have to develop a theory and then develop a concrete observable hypothesis test where our theory can fail. Okay, a theory that can't fail, if you have a hypothesis test that can't prove your theory wrong, then your hypothesis test is no good. You have to have a hypothesis where your theory can be proved wrong in order for you to believe that your theory might be correct. Okay, so we're going to formulate that theory. We're going to develop a concrete observable test. We then use a testing method. We're going to talk about those: descriptive, correlational, experimental, to actually gather that data, those data. Then you analyze these data, uh, crunch your numbers, do your statistical analysis. And then the most important part is you then share your results with other scientists. Now, why is sharing your results the most important part? Well, science is only good if people know about it, right? And so the idea is that the scientist shares their results, and then other scientists can develop their own theories and test their own theories that relate to what the researcher is doing or testing. Science is a collaborative process. This is why there are scientific journals out there. The idea is that we're all discovering things about the psychological functioning of humans. What we have to do is then share those results so we can build as a group. Okay? Now, things to keep in mind: a theory is only good if it's disprovable. Theories are always temporary. They can and should be changed or discarded if we have new data. I don't know if you've noticed over the last couple of years, we keep getting changing advice from the CDC and from the World Health Organization about whether or not we should wear masks, what masks we should wear, which vaccine works good, which vaccine works better, how many vaccines we should have. And some of you have probably been a little bit disturbed about the fact that sometimes we keep getting uh, different statements from the CDC. And that's because their theories are temporary. And as they gather new data, they come out with new theories to help guide the public. Okay. Now, this doesn't mean that the CDC doesn't know what they're doing. What they're telling you is that as they get new information, they change their recommendations. And you should always be willing to be that kind of person to change your opinion or your theory if you get new data. All right. And just remember, as I said, sharing your results allows the community grow their theories as well. There may be hundreds of people working on self-esteem, and those people might be interested in understanding what you've discovered about the link between the number of friends somebody has and their level of self-esteem. And so each and every one of us is in an obligation to share that material. Do we have any questions so far? Does that make sense? All right. Quickly speaking, your book's got a chart that looks like this one right below me. And what it suggests to you is that there are three broad methods for gathering research data. There are descriptive methods, there are correlational methods, and there are experimental methods. Now, each of these different ways of gathering information has their own advantages and their own disadvantages, as I'm going to list in the following PowerPoint charts. Okay, so descriptive methods is just when you go out and you observe people in their real setting, or you bring them in your laboratory and you observe them. And this is good for preliminary research or unique situations that you can't create experimentally. All right. There are other methods that are used when you have more information or you want a more refined study or test of your hypothesis. The second group is in blue down here. Oh, and you'll notice that there are three different types of specific descriptive methods. We're going to talk about those three briefly too. Now, you'll notice in the blue box, the second type of research method is the correlational method. And this is good for looking at associations among variables and allowing us to see how one quality of a human is linked to another quality or behavior that that human may engage in. And so this is good for looking at associations among variables. However, the lack of experimental control in these situations is going to prevent us from making really definitive statements about relationships between human qualities. In order to do that, you really need this thing called an experimental method. Notice it's below me in green. This is the hardest research situation to set up, but it allows you to demonstrate this thing that we call the gold standard in science, the causal relationships. I don't know if you remember back from your science class, but your teacher may have told you that science is interested in predicting behavior, predicting outcomes. The reason science is interested in prediction is because if you can predict something, you truly understand what it is you are studying. If you know how something's going to act in the future, then you really have a firm grasp on what that is. And so experimental methods are best because they allow us to predict when things will happen. Okay? Descriptive methods. There are three different types of descriptive methods. The first are observational studies. You know, psychologists spend a lot of time just observing people's behavior, people's talk, people's play, and you can learn a lot from simply observing and carefully recording what it is you see. Now, this observation can't be willy-nilly. Instead, you have to develop a very systematic process. What am I going to measure in this situation? How am I going to define what it is I'm measuring? How am I going to count what it is I'm measuring? So in the observational study, a researcher creates a very systematic process for making observations and measurements on the behavior of individuals of interest. Now, you can do this two ways. The psychologist can go out in the real world and observe the human being in their natural setting, or the psychologist can bring the human being into the laboratory and give them a set of tools or artifacts or toys or whatnot, and then watch how the individual behaves in the laboratory. Now, so we have what we call naturalistic observations and laboratory observations. In both of these settings, the researcher simply brings the person into the researcher simply systematically measures the behavior of the organism. Now, the only difference here is that while laboratory studies allow the researcher a little more control, so I can decide which toys I'm going to allow the child to play with. Um, so there's a little more control in a laboratory observation. However, organisms, if they know they're being observed, may not act naturally, which is why you might want a naturalistic observation. I remember I went to a talk one time given by a behavioral psychologist who talked about hand washing behavior. And this researcher would hang out in the bathrooms on his college campus and watch what people did when they came into the bathroom. He would code what they did when they went into the bathroom. Did they do a zero, a one, or a two? And then when they came out, he would measure whether or not they washed their hands or used soap. So he would have a zero for not washing the hand, a one for washing the hand but with no soap, and a two for washing the hand with soap. And this researcher was able to document and describe people's hand washing behavior on college campuses. This is a naturalistic observation. Now, the most famous laboratory observation probably ever, and we're going to talk about this in chapter 4, developmental psychology, is one done by Mary Ainsworth. It's called the strange situation experiment. And she would bring an infant child, as you see in the picture over here, into a laboratory playroom with their parent. She would then have the parent get up and leave the child during the play period, and the child would cry like you wouldn't believe. And then the mom would come back in, or the primary caregiver would come back in. And she observed how the child responded to the caregiver when the caregiver re entered the room. So this is sort of this is a laboratory observation. She was simply creating a situation where the child could play in a room, uh, and then she would measure that child's behavior. Now, the advantage of observational studies is they are rather easy to set up. They work well in new research situations where you don't know a lot. Okay. However, the disadvantage is that the lack of experimental controls makes it really kind of difficult to draw very specific conclusions from descriptive methods. Okay. Now, another way to do research is a case study. And I'm going to talk about several case studies during the course of this semester. Case studies, at least in psychology, are typically done when somebody has brain damage or some kind of problem that is unique and hasn't been seen before and leads to very specific behaviors, thoughts, feelings, or activities. And psychologists have learned a ton about how the brain works by studying people who have brain damage and lose specific abilities. So you can think of a case study as an in depth study of one individual or one group, if you will, one unit, usually one with a unique situation. And these unique cases help us to develop insights into how the brain and nervous system works. So if I know that this part of your brain is damaged, and then I know that you can't do X, I may really be able to conclude that this part of your brain helps you do X behavior. So they allow us to study situations that would be unethical to study experimentally. So if I wanted to find out what this brain part does, I can't go in and experimentally damage it on people, right? That would be completely unethical. And so it really works well in these situations where it would be unethical to do a research study. However, individuals are all unique, and it sometimes can be hard to generalize a statement about an entire organism based upon looking at one organism, right? So just because you had brain damage there and you couldn't do behavior X, that doesn't mean that for everybody, this part of the brain controls behavior X, right? So descriptive case studies do have advantages and disadvantages. Let me see. Where? Oh, where? Huh. Famous case studies. I have my files out of order. An example of a really famous case study was Jeannie the Wild Child. I don't know if anybody ever heard of Jeannie the Wild Child. She was raised in total isolation the first 11 years of her life, and she was not exposed to language. When she was rescued at age 11, doctors were very interested in discovering whether or not this girl could learn to speak language, and it turns out she couldn't. And so we now know that there is a critical period for language development. If you do not get exposed to language within the first 5 years of your life, it will be impossible for you to learn a language. And I promised you that I would tell you why HM uh, couldn't remember anything new. It turned out that HM had to have brain surgery for severe seizures. Severe seizures. They removed this part of his brain called his hippocampus, and his seizures got much better. However, HM was never able to remember anything new after that point. So we now know that the hippocampus is the part of the brain that helps us to make new memories. And there have been a couple of more famous case studies about people with damage to their hippocampus. And the weird thing is, they really can't remember anything new. And they can't even keep a memory in their brain for 10 minutes. That's how important the hippocampus is. Now, Trevor Braverman asks a good question. Do the rules on being unethical bend at all for any bodies debated to science? You know what? It turns out that there should be a standard set of ethical guidelines for scientists that we all have to follow. So we do no harm, no permanent harm to anyone in order to do research. If we are going to harm animals, we have to show great cause for why it's important to humans, whether or not you agree with that or not. That's a good question. There's ethical principles not to lie, not to present false data, um, and there are other ethical responsibilities. And Trevor, these should be rules that everyone has to follow, but not everybody does. That's a great question. Okay, now, really, if you want to really be strong in making a statement of cause, what you need to use is an experiment. Experiments allow us to demonstrate causal relationships between variables. And what we do is we look at two variables that happen to be interesting to us, right? For bodies, don't do the rules ethical bend at all? That's a that was the question you were asking. Right. No, they do not bend for donated bodies either, because your body cannot be used unless you give permission. So all research studies require that the participants give what's known as informed consent. And if anybody was ever interested, I could tell you about half a dozen different research studies that were done here in the United States without the consent of the people who were studied. Um, and so that's a good question, Trevor. There's no harm to be done to a body that's already dead. However, you still have to be able to give your consent. Did I miss surveys? Oh. You're right. I'm so sorry. Thank you, Sarah. Thank you, Sarah. Before we go on to experiments, surveys. Now, uh, thank you, Sarah. I had my things out of order. Surveys. The final descriptive method is surveys and self-reports or tests. There are tons of personality tests that psychologists use. There are personality tests for normal personalities. There are personality tests for abnormal personalities. We can now measure this thing called IQ, which is similar to intelligence. We can measure self-esteem. We can measure personal control. There are surveys that study how we romantically bond with other people. There are stress inventories. We can measure psychological disorder qualities like depression, anxiety, and even schizophrenic thinking. And so, one way in which psychologists gather information is by using surveys and self report measures. And so, self reports are simply a descriptive method that involves asking questions of research participants. Participants then respond any way they feel is appropriate. Now, the advantage of these is they're really, really easy to administer. Okay, there are very few ethical uh, problems with administering surveys other than making sure the person gives informed consent for you to use their opinions. Surveys usually don't have any ethical problems. They're very straightforward. And you know what? When you ask people to tell you how they feel, I mean, how much more direct can you get on a research method? The only problem with surveys is mentioned here in this little chart here. Some people have what's known as a self-report bias. People tend to think of themselves positively, and so people tend to forget the bad things they do and exaggerate the good things they do. Sometimes people lie on purpose because they don't want to tell you the truth, or they know that their opinion is going to be unpopular. And you know what? Sometimes people just really don't know how they feel about things. They haven't thought them through. And so if you give somebody a survey question, they may not know how to accurately respond. So the three ways to engage in descriptive research, okay, they are observational studies, case studies, and the use of surveys, self-reports, and other test materials. Okay. Now, the second way to do it to gather data is probably the best, and that's demonstrating causal relationships between variables using an experiment. So, in an experiment, what you do is you find the cause or the thing that you think is of importance, and that's called the independent variable. You then you then compare variations of that independent variable against one another to see if they differ in their effect on the dependent variable or the effect. So an independent variable is a variable that impacts another variable. Wow, that's a lot of variables. And the dependent variable is the outcome think is impacted by the independent variable. Let me explain this to you with a demonstration. Okay, I'm going to my whiteboard right now. Okay, hopefully everybody sees that. I have this theory called the educational proximity theory. I say the closer students are to educational objects, the more they are impacted by the content of these objects, right? And we can argue that happens for any number of ways. Maybe their sensory devices can perceive the information. Maybe they're more excited by the information. Their heart starts to beat faster, and they're more engaged when they're close to educational materials. And so I have this thing called the educational proximity theory. Now, my hypothesis says that if that is true, students who sit in the front of a classroom will make higher grades on the test than those students sitting in the back of the classroom. That's my hypothesis test. Now, if I could, what in this particular statement, what is the cause? Can you tell me what the cause is in my hypothesis and what the effect is in this statement right here? Take a look at my hypothesis. What's the cause and what's the effect? First tell me the cause. And I'm going to wait just a second and then I'm going to start writing the cause down myself. Hopefully you know what I'm talking about. The cause is, okay, the cause is how close to front of the class, right? Exactly, Mizo. And so what I'm going to do is I'm going to compare those people sitting in the front of the class with those people sitting in the back of the class. And what is my dependent variable? What is exactly causes the student? Nope, Isaiah, the student performance in the class is actually going to be the dependent variable. We think their location is the cause, and sitting in front effect, better grades. There you go. Very good, Zara. Okay, so your grades. So here's my classroom right up here. You see these dots? And I have the first row, I have the second row, I have the third row, and I have the fourth row. And I have 5 students in each row. And here's the teacher right here. You see this? So what I'm going to do is I'm going to split the class and I'm going to compare the grades in the back with the grades in the front. All right. So what I'm going to do is I'm going to come in the first day of class and I'm going to teach my lectures for the first 2 weeks. And I'm going to make sure everybody has to sit in the same exact seat. And at the end of the first exam, I'm going to look at the grades of all the students and I'm going to take the average of the grades in the back and compare them to the average of the grades in the front. All right. And if there is a difference, then I have supported my hypothesis that students sitting in the front of the class will make higher grades on the test than those sitting in the back of the class. Now, there's one important point that I have to tell you about, and I glossed over it. In order for you really to be able to demonstrate cause, you need to use this thing called random assignment. This is the key to the experiment's ability to demonstrate cause. And random assignment allows the teacher to create 2 groups that are most likely equivalent at the beginning of the study. Now, let's go back to my whiteboard here. If I let students come in and sit wherever they want, might the students sitting in the back of the classroom be different than the students sitting in the front of the classroom if I let them do that on their own? What's the difference between a student that chooses to sit in the back of the classroom and a student that chooses to sit in the front of the classroom? Are they different, maybe? What do you think? You know, for me, I've always thought that students maybe who are better students choose to sit in the front, right? Exactly. The ones who sit in the front want to listen. Isaiah and Gabrielle both got it. So here's the deal. I can't let the students choose their own seat. I have to choose the seats for the students the first day. All right. And I do that using a process called random assignment. And that allows me to make sure that the students in the front of the class aren't different than the students in the back of the class. Ooh, the social interaction may be different. Right, right. Okay. Now, here's the deal. In order for you to really have two groups that are most likely similar, you have to use random assignment. That is, you have to allow them to, you have to assign the students yourself. You can't allow them to pick their location one way or the other. So let's do it this way. Somebody give me answer this question. Here's what I'm going to do for random assignment. As my 20 students come into class the first day, I'm going to tell the first 10 that they have to sit in the front of the classroom, and I'm going to tell the last 10 who show up that they have to sit in the back of the classroom. Have I achieved two groups that are equivalent, or might I still have difference between the people in the front of the classroom and the people in the back of the classroom? What do you think? I'm going to assign the first 10 that come to the front of the classroom, and I'm going to assign the last 10 to the back of the classroom. No, I still haven't achieved random assignment. And why might there be a difference? Why might there be a difference still? If I if I tell the first 10 students who come to class to sit in the first two rows. Hmm? Is there something that might affect whether or not you come to class early? Friends come in together. That's a good hypothesis, Isaiah. And also, maybe more motivated students come in earlier, correct? Maybe motivated students. So, really, in order to you, exactly, the first ones might care more. So, really, in order to create true random assignment, what we have to do is we have to take all ability of the students to choose where they sit. And so, a good example might be for me to write a one or a two on each on 20 slips of paper. And as a student comes into the classroom, I have them reach into the hat and draw a number out. If they draw a one, they have to sit in the first two rows. If they draw a two, they have to sit in the back two rows. All right. So if I use random slips of paper or numbers or a random number generator, then I can create random assignment. Now, the deal is if you have random assignment, and we know our two groups are most likely similar at time one, and then we measure them and they differ based upon the independent variable. We know that it's not because these two groups are different, but because somehow or another the independent variable has an effect. So if you look at this chart way over here, you'll notice it has your independent variable in the bottom column, and it's split into a control group or an experimental group. Those terms aren't as important as they sometimes sound, but in ours, we would have back of the classroom versus uh, front of the classroom. I'd then teach the lecture for a month, and we'd then administer the dependent variable. We would take a test, and then we would look at the data and analyze the results, and we would say, are the average grades of the students who sit in the front two rows different than and or higher than those who sit in the back two rows? And if we did, we would then say that we can argue that students who sit closer to the board do better than students who sit farther away from the board. Okay, this would be a true experimental demonstration of this hypothesis. Now, the neat thing of this is that the experimenter has so much control and knows that they're comparing the same number of people in the same exact situation. This allows us to say things like A causes B. Sit where you sit in class causes your academic performance to improve. We can say stuff like that. The only problem is, in order to do a true experiment, a lot of times we have to make a situation kind of artificial, and it doesn't look an awful lot like the real situation that we're interested in. So there are advantages to experiments and advantages and disadvantages to experiments too. All right. The final thing I want to talk about, sometimes we want to look at a relationship between two variables, but we don't have the ability to assign our people to one situation or another. Now, in a classroom, I can assign students to sit in the front or the back of the classroom. But you know what? What about if I'm interested in the effect that economic uh, uh, position has on your school ability as a child? I might say that I think that economic ability really improves your academic performance. Kids who are wealthy do better in school than kids who are not wealthy. I'd really like to know that. But you know what? I can't really assign people to be wealthy or not wealthy. I might want to say, you know what is the effect of somebody having an alcohol problem have on their ability to engage successfully in a romantic relationship? Well, I can't ethically make someone become an alcoholic, right? However, I'm interested in the effect that income, that gender, that sexuality, that smoking, then alcohol use. I'm interested in the effect that in the relationship that all of these variables have to other human qualities. And so, even though I can't set up an experiment, I would like to look at these relationships. In this case, I'm going to use what's known as a correlational study. And a correlational study simply measures two variables uh, to see if these variables change in concert with one another. Okay, so for example, what you might do is I might want to see how if there is a link between IQ, your intelligence quotient, and your ability to do well in school. So you know what I might do? I might take 100 people, and I might let me show you on the whiteboard. I might take 100 people and I might say, what is your IQ score? I might measure their IQ score, and it might go from 50 all the way up to 150. So, intellectual dysfunction all the way up to genius. And then I might say, how many years of school did you achieve? And we go from I finished the first grade to all the way I got my PhD, which is 20 grades of school, right? And what I might do is I might measure a bunch of people's IQ and then ask them how many years of school they got done. And each person gets placed on this chart based on their two scores. And what we're looking to see is there a relationship? So you'll notice that there seems to be a relationship such that as our IQ gets higher, the number of years in school gets higher. And this is what we might call a positive correlation. Okay? And that's simply the simple way to do a correlational study. Now, there are also these things, and you'll notice in the chart over here on the far left-hand side of the board, you'll see we have a positive correlation. So this shows as one variable increases, the other variable increases as well. This is a positive correlation between IQ and academic achievement. Sometimes when we measure variables, we find that there is a negative correlation. That is to say, as one variable increases, the other variable decreases. Here's a negative correlation, which may or may not surprise you. Alcohol intake and academic performance in college are negatively correlated. The more beer you drink every day, the lower your grades will be in college, right? And so, the easy way to do this would be to go to students who have finished 1 year of college, and we ask them to tell us how many beers did you drink every day on average, and what was your GPA? And you know what we might find if we did that? We might find the exact opposite relationship, right? So we would do number of beers from 0 to, let's say, 12. And then we could do their GPA from 4 down to 0. And what we might find is this type of relationship here. which would be a negative correlation. A negative correlation, right? Now, the problem with the advantage of correlations is they can allow us to study relationships between variables when an experiment is unethical or impossible to set up. Correlations can also be done in real world situations on variables that represent catastrophic or dangerous life outcomes for people. So, what happens when you have cancer? What happens when you have an alcohol problem? What happens when people choose to do these different things that we would normally not be able to make them do? We can look at how these behaviors and qualities affect people's life outcomes. So they can be done in real world situations. The only disadvantage is that we cannot prove a causal relationship between two variables using a correlation. Okay, fantastic. Well, we are at 9:45. Do we have any questions? I notice we've still got a pretty good audience here. I'd like to thank everybody for coming today. Any questions about chapter 1? Okay. Now, here's the deal. I will be doing a webinar tonight at 7 p.m. We'll be talking about the areas of specialization in psychology, just like we talked about on Tuesday. It's the same webinar that I gave Tuesday night. So if you were there Tuesday night, you do not need to come tonight. Um, but if you want to do your discussion board by attending the webinar, your collaboration by attending the webinar, you can do that. If you don't have time or you don't have the interest to come to the webinar tonight, you are more than welcome to do your collaboration activity by completing the discussion board this week. Okay? It was great to see everybody. I really want to thank you for coming to the lecture. Um, I appreciated seeing each and every one of you. Thanks to all the questions I saw on the chat board. You folks are, of course, very interesting and thoughtful, as I've always found Wake Tech students to be. And I hope you folks have a great day. Look forward to seeing you. Oh, no, tonight's webinar is at 7 p.m. Tonight's webinar is at 7 p.m. I do a late one on Tuesday and I do an earlier one on Thursday. Okay, so tonight's webinar is at 7 p.m. and I'll send a reminder. It will be in Teams, and the webinar will be in Teams. Tiffany asked a great question. The webinar will be in Teams tonight. No problem. Thanks for coming today. Everybody have a great day, and don't forget to smile, all right? Take care, and I will see you next week.